Many metal products, such as chemical tanks or aircraft frames, are made from a number of metal parts. These have to be joined together effectively. Otherwise, there is a risk that the joint might become loose in service and the product could fall to pieces. Electric arc welding is a commonly used process that provides permanent, strong joints in metal products. There are many different types of electric arc welding, such as TIG, MIG, flux cored, sub-arc, and manual metal arc welding. In this video, we will look at how MIG welding is used to join two pieces of metal. MIG welding is an abbreviation for metal inert gas welding. It involves using an electric arc to melt the contact area of the parts being joined. This forms a puddle of liquid metal, which is moved along the edges of the parts to create the joint. In MIG welding, the arc is formed between the metal parts being joined and a metal electrode, which melts to add extra metal to the puddle. This allows a joint to be made, even if there is a slight gap between the parts. The first step in joining two metal parts is normally to clean the surfaces to be joined. The parts are held or clamped together. It is important that they fit together well. If there is a large gap between them, it is too difficult to create the puddle of metal and therefore not possible to weld. Any grease, dirt and rust have to be removed, or these could stop the arc melting the metal in the right place or contaminate the joint, causing it to be weak. Rust is removed by machining or grinding the surface of the metal. The next step is to tack weld the joints. This involves making a very small weld at just one or two positions on each joint. This is very important, as the heat from the full weld will cause the metal to expand. This may cause the metal being joined to change shape, creating gaps in the joints that cannot be welded, or meaning that the shape of the product will not be as intended. Once the parts have been tacked together, the dimensions and angle of the joint should be measured to make sure that they are correct. This allows any problems, such as distortion due to heat from the tack welding, to be identified and corrected. If necessary, tack welds can be removed by grinding and repeated, although this is a very time-consuming process. Finally, a weld is made along the full length of each part to be joined. The welder wears a helmet with an eye screen made of dark glass, so that he can see the bright arc and the weld puddle. If he tried to look at this without the dark glass, it would damage his eyes. He wears gloves because the arc and weld puddle give off a lot of heat, and the parts being welded will also get hot. For a successful welded joint, the welding nozzle needs to be held at the correct angle. Also, the power setting and speed settings for the wire feed need to be correct for the particular thickness of material. Inert gas flows through the welding torch, which prevents the formation of oxides that would otherwise stop a successful joint. The smoke produced by welding, which is called welding fume, is poisonous. This is often collected by a fume extraction system. The end result should be a strong, permanent joint. After welding, the joint will probably be cleaned and painted to give a professional appearance and to help defend against corrosion.